This is section 151. We're going to take a look at function arithmetic. So we're going to perform different function operations. In the previous section, we used a new type of function notation to make sense of expressions like f of x plus 2 or 2 times f of x, 2 times whatever our function is for a given function f. It would then follow that functions should have their own forms of arithmetic. Now, I want to be very clear as we go through and interpret these. This idea of f of x does not mean f times x. It's a special way of stipulating that this input-output relationship is a function. And so it's a fancy way for us to write it. If I wanted to say I want to add two functions together, instead of just writing f, I could write f plus g, with this still being my input. This is the same as if you just took the f function and added it to the g function. If I wanted to subtract two functions, f minus g, it's the same as taking your f function and then subtracting it from your g function. If I wanted to say f of g of x, and this of obviously does mean multiplication. This one is referring to the input. But this is implying that I'm going to multiply my two functions. And at last, for this one, this is dividing. And so I'm going to divide my two functions. So with these two functions here, 6x squared minus 2x and g of x equaling 3 minus 1 over x, let's find f plus g, and then input -1 into my function. So the first thing, I'm adding my two functions together. So I want to do that first. I want to add my f function to my g function. And so instead of it being x, I'm going to be using -1. So to find what f of -1 is, I take -1 and I plug it into my function up here. So 6 times -1 squared minus 2 times -1, and then find g of -1, 3 minus 1 over -1. Doing each of those separately, entering our calculator, simplifying it, you get 8 and 4. So then f of -1 is 8, g of -1 is 4, 8 plus 4, you get 12. Now we're going to find the domain of g minus f and find a formula for it. So remember, if we're subtracting, that means you take the functions and you subtract it. Because it says g minus f, we're going to take our g function and subtract it from our f function. So there it is. This right here is our g function, and I'm subtracting it from my f function. Now I got to distribute that negative. And then now I rewrote it in descending order. So it's -6x squared, so then I have the 2x, then the 3, and then the 1 over x. So now, if you remember a few lessons ago, we looked at the domain, and we said, well, what are some of these restrictions? One of them was a negative inside of a square root. So do I have x inside of a square root? No. The other one is going to be what happens if I divide by 0. And so, because I am dividing by x, it is possible for me to divide by 0. So I want to do is I want to take that and say it can't equal 0. So whatever was in the denominator, in this case it was just x, you say it can't equal 0. Now I can take that, put it on a number line. So it can't equal 0, so open circle, but it can be everything else. And so my answer is going to be -infinity to 0, union from 0 to infinity. The next one is just saying f times g with my input 2. So depending on how you want to do it, you can plug 2 into your g into your f function first. That's a way to do it, and then multiply it together. So if I wanted to find my f of 2, this is what it's saying. You're taking your f function with 2 plugged in and your g function with 2 plugged in. So if I wanted to find my f of 2, so plug in 2, So 2 squared is 4. 24 minus 4, so you get 20. So this is 20 times, now your g of 2, now I need to simplify that. Find the common denominator. So multiply by 2 over 2, so you get 6 over 2 minus 1/2. So that's going to be 5/2. Now just simplifying that, this is 20 over 1. 20 and 2 cancel out, so you get 10 times 5, so you get 50. And the last one, divide. Take your f function and divide it by your g function. So we'll take our f function, we'll divide it by our g function. Now the domain, we have to look at it and say, okay, can I divide by x? Well, I have an x in the denominator here, so 3 minus 1 over x can't equal 0. And I have an x in the denominator here. X can't equal 0. So I have to solve for both of them. Well, that one's already there. My next one, I could subtract 3 on both sides. Divide by a negative. Multiply by x. Divide by 3. So I get 1/3 can't equal x. So these two are my domain restrictions. So I'm going to plug those into a number line. I said I never stipulated that it can't be anything else. And so my domain is going to be from -infinity to 0, union from 0 to 1/3, union from 1/3 to infinity. So what did we learn today? We talked about using function notation. Now remember, the focus, we know how to add, subtract, multiply, divide polynomials. The focus is more on the notation because we're going to see it later on in class. So what's another way to visualize f plus g of x? That's the same as f of x plus g of x. And what's another way to visualize f over g of x? That's the same as your f function divided by your g function. This does conclude our lesson. If you have any other questions, please leave them in the comments.